Hi, my name is Logan and I'm a graduate student at Johns Hopkins University working in the Panetti Lab. I'll be studying organometallics and photochemical mechanics. In this video, I will introduce the concept of photochemistry and showcase where this science is applied in everyday life. Photochemistry can be seen in the technology and products we use throughout the day, and most people around the world are completely unaware of it. The human eye is thought to be one of the most complicated organs in the body, and many people do not truly understand the biological infrastructure that is necessary for us to see. So how do we really see? What is going on inside the human eye that allows us to take in visual information and process what we are seeing? What chemicals or molecules inside the human eye allow us to see? And finally, how is light and photochemistry involved in all of this? So the human eye is performing photochemical reactions all the time. A protein inside the eye, called rhodopsin, is one of the main photoreactive features that allows the eye to take in information and convey it to parts of the brain that allow for more visual processing. If we look inside rhodopsin, there exists a molecule called retinylidene. In the dark, or when your eyes are closed, retinylidene exists in its inactive conformation, or cis conformation. When you open your eyes and expose retinylidene to light, it changes shape, or as chemists say, isomerizes. This is retinylidene's active state, or transconformation. See how the shape of the molecule changes? This results in a cascade of chemistry that allows us to see. So what really is photochemistry? Well, photochemistry is a study of how light can affect chemistry. You probably already know countless things throughout the world that harness photochemistry. Photosynthesis is a very common biological process that utilizes light from the sun to produce energy inside plants. It is important to understand that without light, this energy creating and storing mechanism would not be possible. Another relatable example is glow-in-the-dark toys, including those fun stars you put on your ceilings as a kid. These decorations have specific chemicals that release energy in the form of light in the dark after being in the presence of light throughout the day. Finally, another form of photochemistry in life is laser hair removal. In these procedures, a chemical reaction caused by the lasers releases heat in the stems of hair follicles, ultimately destroying them and inhibiting them from growing back. These are just three very common examples in which you may see photochemistry throughout your day. Now, let's get into the specifics of how chemists think about photochemistry. For an example, let's think of molecule A. Now, what is in molecule A? Firstly, electrons, and secondly, the nuclei's placement. The electrons around the nuclei dictate both the shape and the reactivity of these molecules. Light allows us to change how these electrons act around these nuclei. Now, as chemists, we interpret these building blocks to form interactions inside molecules that cause them to be constantly in a dance. Now, we do not mean a dance in a literal sense of movement, just that the molecules behave in a certain way in normal conditions because of their internal pieces. Let's imagine for our sake that normal molecules always dance in a circular motion. And to be more specific, this dance happens when the molecules are in the dark and nothing is happening. As you can see, the same motion as before is observed. Scientists often refer to this concept as the ground state of the molecule. In the presence of light, and light that contains a high enough or specific amount of energy for the molecule's dance we have been talking about changes drastically. As you can see now, the molecule is full of new life and energy. Scientists refer to this as the excited state, and this is the essence of all photochemistry. Here, in the excited state, is where all types of photochemistry take place. All the reactions and processes I talked about earlier, like photosynthesis, laser hair removal, and the glow-in-the-dark toys, happen from the excited states of the molecules. Now, our excited molecule can go through three different paths back to the ground state. Firstly, the excited molecule can release energy in the form of heat to return to its ground state. This can be observed in laser hair removal and sunscreen, where the chemicals in the lotion take in light and release small amounts of heat to save your skin. Secondly, the entire excited molecule can undergo a chemical change to become something new. usually a more stable product. This is observed in plants through photosynthesis and some UV water treatment plants around the world that purify wastewater with light. Finally, the excited molecule can return to the ground state via the release of light in processes known as fluorescence or phosphorescence. This is observed in glow-in-the-dark decorations and even some wildlife like scorpions, whose exoskeletal shell is luminescent due to the photochemical dyes in their bodies. Overall, these three methods to returning to the ground state are harnessed by scientists to perform chemical reactions every day. To wrap everything up, let's talk about some important photochemical achievements. In 1923, Albert Einstein finally discovered the photoelectric effect, which determined that electrons could be expelled from metal surfaces upon light introduction. This was groundbreaking in the field of photochemistry and developed new ways of understanding how everyday molecules interact with light. In 1959, photolithography was finally invented, which is a photochemical process that can etch extremely small and detailed patterns onto computer chips. This preparation method is still widely used today and is the main factor in the development of all modern technology. In 1978, researchers first discovered that light could be used to destroy certain types of cancers in mice. This technique would be described as photodynamic therapy, and it was the first time light was proven to selectively release drug molecules into cancer cells in animals. This science is still widely being studied as a cancer therapeutic, and the idea is used in some modern facial cleansing techniques. In 1987, the modern organic light-emitting diode, or OLED, was developed, which is similar to the regular LEDs we know today, but utilize organic compounds to produce the spectra of light emitted. These OLEDs are still used today in nearly all computer, television, and phone screens. In 2016, the Chemistry Nobel Prize was awarded to Jean-Pierre Sauvage, Sir Fraser Stoddart, and Bernard Feringa for the design and synthesis of molecular machines. These molecular machines are a class of molecules that are similar to common machinery at the microscale. One of these molecules was determined to be a molecular motor and would spin like a motor after exposure to light. And finally, in 2023, the Chemistry Nobel Prize was awarded to Muji Bawendi, Louis Bruce, and Alexei Yekimov for the discovery and synthesis of quantum dots. These nanomolecules were discovered to be tunable for their light emission, where changing the size of the small particles would effectively determine the light emitted from them upon photoexcitation. Overall, I hope these inventions and discoveries showcase the importance of photochemistry in our day-to-day lives. And thank you for taking the time out of your day to listen to me talk about a topic I am deeply interested in. And I hope you learned something new today that excites you as well. If you want to follow our group, follow along at panetti-lab.com.